From sonnets to love songs, the stars have always been a source of inspiration for us. We've gazed at them, wished on them, studied them. But can we hear them? It turns out, with a little bit of help from Asteroseismology, we can. Just like seismology is the study of earthquakes, astroseismology is the study of starquakes. Both fields of study use quakes to understand the interior of celestial bodies. Now, on Earth, the slow movement of tectonic plates builds up pressure, and that pressure can suddenly be released in the form of earthquakes. These quakes are waves, seismic waves, that carry all of that built-up energy through the Earth.
As the waves travel through Earth, they bounce off of certain materials, like iron in the Earth's core, before reaching the surface. Seismologists can measure the waves that do reach the surface and use their characteristics to estimate the interior structure and composition of our planet.
On the stellar scale, though, the process is a little bit different. Stars are hot gaseous spheres, which means that their molecules are always moving, so starquakes are always happening. In fact, starquakes are also called stellar oscillations because they happen in a regular pattern. It's not like the Earth, where slow movement eventually leads to sudden bursts of energy. In stars, the molecules are always moving, so they're always releasing some energy. This energy travels through the stars as waves, and these are starquakes.
As waves travel through the gas of a star, they press together molecules when the wave compresses and release others when the wave expands. And when gas is compressed and expanded, it creates sound. So the waves of starquakes are really sound waves.
In fact, if we could dive into a star, we would hear these starquakes. It would be a stellar symphony. Of course, this is impossible. We wouldn't survive jumping into a star, and sound waves can't travel through the vacuum of space. But that doesn't mean we can't take part in that stellar symphony. It just requires a little transposing of the music. Because while sound waves can't travel through a vacuum, light waves can. And it turns out starquakes don't only create sound in stars, they can change the star's brightness. Using very precise telescopes, like NASA's Kepler telescope, astroseismologists can measure the tiny variations in the brightness of a star that reveal stellar oscillations.
These variations are graphed as functions of time, and surprise, surprise, they come out looking like waves. Sometimes, though, the waves have periods of years, so we have to shift the waves into the audible range of humans.
This process is called sonification, and it opens the door to a whole universe of stellar symphonies. Here's one from NASA, based on an image of deep space from the Hubble Space Telescope. Best of all, sonification makes astronomy a field everyone can enjoy. The visually impaired can be astronomers too, letting us all find new inspiration in the sounds of the stars.